Hi everybody. So in today's video, I'm going to be going through the practice test with you and just making sure that you know how to do all of the problems on the practice test. So right now I am on slide number 1 in ClassKick on the practice test, and we are going to go over how to do these problems. In the directions here, it says that we have two functions. We are given f of n and g of n. And we are asked to evaluate the following functions with the indicated values. So problem number 1 here says find f of 2. Now, when you see find f of 2, what that means is that we need to plug in the number 2 into the f of x function and replace the n with a 2. So when I do that, I'm going to have 3, and then I'm going to put a parentheses, and I'm going to put the number 2 on the inside. And then I'm going to copy down the -1. So all I'm doing is taking the exact equation for f of n and just replacing the n with a 2. After that, I'm just going to use my calculator to find my final answer. And my final answer here would be the number 5, because 3 times 2 is 6, -1 would give me 5. For problem number 2, we are asked to find g of 1. And what that means is that we're going to plug in the number 1 into the g of x function. So what I'm going to do is find the g of x function in the instructions, which says -3 to the nth power. And I'm just going to replace the n with a 1. Now, I'm going to use my calculator and type that in, and -3 to the first power is going to just be -3. And that would be my final answer. For problem number 3, I need to find g of 4, and g of 4 just means take the number 4 and plug it in. So if I plug that in, then my new problem is going to say parentheses -3 to the 4th power. And again, I can use my calculator to type that in, and the answer will be 81, because -3 times -3 times -3 times -3 makes 81. And the last problem here says find f of p. F of p means just plug in p instead of the n in the problem. So I'm going to take the f of x function, and I'm just going to replace the n with a p. And then I'm going to copy down the -1 from the original equation. Now, in my other problems, I was able to type in my problems on the calculator and actually get an answer. However, in this problem, since I still have a variable in my expression, 3p minus 1, I can't type that in. So this would just be my final answer for the problem. All right, let's go to slide number 2. So on slide number 2, I am asked to use the formula below to generate the first 5 terms of the sequence, starting with f of 1. So one of the important things to realize here is that it says specifically to start with f of 1. When it says that, I like to start by just labeling which one of these lines represents which term. So this is going to be number 1. I used the highlighter. This is going to be number 1. This is going to be number 2. This is going to be number 3, 4, and then this will be 5. Now, in order to find those values, I'm just going to take these numbers and plug them in into the equation. So, for example, the first thing that I would do here is I would find f of 1. And to get that value, I would just replace the x in the equation with a 1, just like we did on the previous slide, except for now we're just going to do that a bunch of times. Now, -2 times 1 is -2, plus 3 would just give me 1. So my starting value here would be 1. Now I'm going to find f of 2. So all I'm going to do is the exact same thing, but replace the x with a 2 in the equation. Now, negative 2 times 2 plus 3 gives me negative 1. And so my next number in my pattern here would be negative 1. Now, I'm basically going to repeat this process for the number 3, the number 4, and the number 5, which means my next numbers would be negative 3, negative 5, and negative 7. And so that would be my terms in my sequence. For problem number 6, it says use the formula below to generate the first 5 terms of the sequence, starting with f of 1. So just like the previous problem, we're starting with f of 1, but this time it gives me a recursive equation. So in this problem, we're going to do this a little bit differently because in a recursive equation, it always tells me the starting value in the problem. So that's going to be my starting value, which means the first term here would have a value of 2, and I can figure that out using the starting value. Now, the other thing I can always see in a recursive equation is the pattern. So it says here that we have 3 times f of x minus 1. What that means is that the pattern to get from one number to the next number would be to multiply by 3. So if I use that pattern here and I multiply by 3, I get 6, and then 18, and then 54, and then 162. And so using a recursive, I think, is actually a little bit easier than using an explicit equation to do this problem. All right, let's take a look at the next problem. So on slide number 3, we are going to be asked to use some vocabulary to describe sequences. So let's start with just deciding if these sequences represent arithmetic or geometric. In the first problem, I can see that there is a multiplication pattern by 2/3. So multiplying is going to be arithmetic. In the second problem, I can see that that's an explicit equation and there's no exponent, so that's going to be arithmetic. For number 9, I can see that the pattern is subtracting 5. So again, that will be arithmetic because arithmetic is anytime we have a subtracting or adding pattern. And for number 10, I can see that there is an exponent. So because there is an exponent, that's going to be a geometric sequence. Now, we are also asked to decide if these are explicit or recursive equations. So in this first problem, I can see that the equation starts off with f of x equals f of x minus 1. So it uses the previous term. What that means is that we have a recursive equation. For number 8, it does not use the previous term, so that would be explicit. So no previous term. For problem number 9, it does use the previous term. I can see that at the beginning of the equation, so that's going to be recursive. And for problem number 10, it does not use the previous term, so that's going to be explicit. Now, problem number 11 is going to ask me to choose a function between numbers 7 through 10. So literally pick one of the problems you just did. And after you choose a function, I want to know how did you determine that it was arithmetic or geometric? So arithmetic or geometric, and how did you know? So I'm going to go ahead and give you an example here. There are lots of right answers to this question. I'm going to just go with number 7 because it's the first one. So I'm going to choose the function in number 7, and I knew that that was geometric because the pattern is multiplication by 2/3. So that's how I got the answer for arithmetic versus geometric up here. Now, the next question is going to say choose a different function or the same function, that doesn't really matter. So choose a function from 7 through 10 and explain how you knew if it was explicit or recursive. So now we're kind of looking at the second column of this table. I'm going to go with number 7 again, and I can tell that number 7 is recursive because the equation uses the previous term. So I'm going to write that down on the lines down here. So I'm going to say I chose the problem in number 7, and I know that it is recursive because the equation uses the previous term. All right, the next thing we're going to do is slide number 4. So on slide number 4, problem number 13 says you are asked to find the 101st term in a sequence. If you know the first term, would it be faster to use the explicit or recursive? So we want to find number 101. We only know number 1. Now, since number 1 is not the previous term to 101, it's not the one that comes right before it, the explicit is going to be easier. And to justify your reasoning here, you would say, because we do not know the previous term, which would be term number 100. We only know term number 1, which is not the one that comes right before number 101. For problem 14, it says James is paying off his car payment each month. The following equation represents his balance. Circle whether it has a common difference or a common ratio. Tell me what the value is and explain the meaning and context. Well, this equation is arithmetic. And the reason I know that is that there is no exponent in the equation. So that means automatically that it's going to have a common difference. Now, I can tell what the common difference is by looking at the number that's next to the variable. So because the m is attached to the negative 220, the value of the common difference is going to be negative 220. Now, if I want to explain the meaning of the value in context, what that means is I need to say, what does that tell me about the story? In this story, we're talking about a car loan, and so we would say the loan amount, and then what's happening to it. So because the value is negative, we would say decreases by 220. And then how often would be each month, because it says that this is the equation for a particular month. On slide number 5 is the first slide where we're going to be asked to write equations. And we're going to be asked to write a lot of equations on this, so I think it's really important to make sure we know what we're doing here. So for slide number 15, when we're asked to write this equation, my tip for you would be to start by making a table of values. So I'm going to start by making a table. I like to always use x and f of x just for consistency. I think it makes it a little easier when I'm writing my equations just to get used to using a certain variable over and over again. So my x values here, if you look at the graph carefully, the x-axis is actually here on the graph. So my first x value is going to be 3, and then my first output is going to be negative 2. Then I'm going to have 4, 1, and then 5, 4, and then 6, 7. Now, after you have a table, I think it's much easier to write equations. So let's start with the recursive. To write the recursive equation, it always is going to start the same way, no matter what. A recursive equation always starts with f of x equals f of x minus 1. And then we need the pattern. Now, in this problem, the pattern is going to be plus 3 each time. So I would put a plus 3 here. After we have that written down, we also need the starting value. So the starting value here would be f of 3 equals -2 because that's the first value that's in the table. When the input is 3, the output is -2. Now for my explicit equation, it's going to start off the same way with f of x, but then we use a little bit of a different technique to write the rest of the equation. So I'm going to take the starting output, which is -2, and then the pattern, which is +3, and then I'm going to put parentheses x, and then I need to use the starting input, which in this problem is a 3. So in order to get back to 0 and sort of reset this table back to where we want, we need to put a -3 here in the equation. Now, the second problem on this page already gives you a table, so part of the work is already done here for you. The first step here would be to just find the pattern. So the pattern would be -20 each time, which means for my recursive, I'm going to again start it the same way. So I would have f of x equals f of x minus 1. You could use other variables. You could use v and t or whatever variables make you happy. But if you want to use f of x every time, that's also okay. And then we would put the pattern at the end, which in this problem is -20. Now we also need a starting value, and the starting value here would be 2 and then 80. So underneath there, we would write f of 2 equals 80. For my explicit, it's going to start the same way. So I would have f of x equals, and then I'm going to put my starting output, which is 80, and then the pattern, which in this problem is -20, and then parentheses x, and then I need to adjust my x to get back to 0. So because this table starts at 2, I would put -2 here by the x, and then end the parentheses, and we're done. On slide number 6, it says Alec is going to be babysitting. Alec considers charging $30 on the first day and two more each day after. So what I would start here is making a table. So I would have days, and I would have how much he charges. It says in the problem that he's going to charge $30 on the first day and 2 more each day after that. So the pattern is going to be +2. So I get 32, 34, and my values here would be 1, 2, 3. Now, to write the equation here, we get to choose whether we want to write the explicit or the recursive, but you don't need to do both. I'm going to go ahead and go with the recursive because it's just pretty easier for me. You could also write the explicit. So an example of a recursive equation would be f of x is equal to f of x minus 1, and then the pattern, which is +2. And then we also need a starting value, which in this problem would be f of 1 equals 30. So if you want to write the recursive, that's what it should look like. Now your other option is you could write the explicit. You don't have to do both, but I do want to show you both answers so that you can check yourself if you do decide to do that. So we would have f of x equals my starting value, which is 30, and then my pattern, which would be +2, and then parentheses x, and then I need to adjust my x to get back to 0, which means I would have -1 here, and then a parentheses at the end. So you could do either one of those, as long as, like, for the recursive, you do both parts, and for the explicit, you get all the values right. Now, problem number 18 is the same thing. We can write the explicit or the recursive, but this time we are already given a table, so part of the work is already done for us. The first step for me here would be to find the pattern. So I would have -30, -30, -30. I'm going to use f of x again because I'm just comfortable with that notation. You could use the variables v and t if you wanted to. Just be careful about making sure the output's on the outside and the input's on the inside. So I would have f of x equals f of x minus 1, and then my pattern, and my pattern in this problem is -30. And then I need my starting value, which would be f of 5 equals 100. So if you want to write the recursive equation, that's the way we would do it. Now your other option is to write the explicit, and if you do decide to write the explicit, it should look like this. f of x equals my starting output, which is 100, and then my pattern, which is minus 30, and then parentheses, x, and then my starting input, which is 5. So minus 5, because we need to get back to 0. Now you don't need to do both, you just need to pick one, and then that will be your answer for that problem. Now on slide number 7, we're going to keep going with writing these equations, except for now we've got a visual pattern. So again, I would make a table. It says at the beginning, at 1 minute, and at 2 minutes. So in my table, I'm going to have x and f of x, because I'm just comfortable with that notation. At the beginning means 0, and there are 3 dots in the picture. After 1 minute, there are 6 dots in the picture, and after 2 minutes, there are 12 dots in the picture. Now, my next step here would be to find the pattern. So the pattern here would be multiplying by 2. If we want to write the equation, we would just say f of x for recursive equals f of x minus 1. So it always starts the same way. And then we need the pattern at the end. In this problem, it would be times 2. Now we are also going to need a starting value. So my starting value here would be f of 0 equals 3, because that's the first value in the table. For the explicit, it's going to start with f of x equals, and then we're going to take the starting output, which is 3, and then this pattern is times 2. And whenever we're using multiplication, we need to use an exponent instead of just a regular parentheses. So you're going to notice I wrote that a little bit smaller, kind of up in the air next to the 2. And then we need to adjust our starting value to get back to 0. Well, since this table already starts at 0, we can just leave this as an x. All right, let's try the next one. It says your parents want you to start doing more chores around the house. They agree to set up a payment system. Doing one chore earns you 25 cents, a second chore earns you 50 cents, another chore earns you $1, and so on. So if I were to make a table of values here, we're going to have the number of chores that we do, and we're going to have the money that we earn. So one chore earns you 25 cents. 2 chores earns you 50 cents. 3 chores earns you $1. It seems like to me the pattern here is that we are multiplying by 2 each time. So when I go to write my recursive equation, I'm going to start it the way I always start, which is f of x equals f of x minus 1. And then I'm going to use my pattern, which is times 2. I'm also going to need a starting value. So my first value here is that f of 1 is equal to 0.25. Now for my explicit equation, I would start with f of x equals my starting output, which in this problem is 0.25, and then my pattern, so times 2, and then to the x power, because if it's multiplication, so it's a geometric sequence, we need to use an exponent. And then we need to adjust our input to get back to 0. So because this table starts at 1, I would need to put x minus 1 here. And again, in this problem, we're using an exponent because it's a geometric sequence and the pattern is multiplication. All right, we're almost done. There are only 2 more problems for us to go over. So on slide number 8, it says Alec considers charging a nickel on the first day and 20 cents on the second day, with the amount multiplying by 4 each day. So again, a good strategy here would be to make a table. So we're going to have the days, and we're going to have how much he's charging. It says he considers charging a nickel, which is 5 cents on the first day, and 20 cents on the second day, and that the pattern is multiplying by 4 each time. So that tells me that the next number here would be 80 cents, because that's what I get when I do 20 times 4. To write an equation here, we could write the explicit or the recursive. You get to pick. I'm going to show you how to do both, but on the test, you're only going to have to do one for this problem. And so our recursive would start off with f of x equals f of x minus 1, and then our pattern, which is times 4. And then we need a starting value. So the starting value here would be 1 and then 5 cents. So f of 1 equals 0.05. Or you could choose to write the explicit equation, which would be f of x equals our starting output, which is 0.05, and then our pattern, and our pattern here is times 4. And because this is multiplication, we're going to use an exponent here with an x, and then we need to adjust to get back to 0. So since this starts at 1, we would put minus 1 here. And again, we're using an exponent because this is multiplication. So if you do decide to write the recursive equation for a problem like this, please make sure, the explicit equation, please make sure you have an exponent. The last problem is going to be this one. We've already got a table of values, so part of your work is already done for you. For our pattern here, it looks like the pattern is multiplying by 4 each time. And so to write our equation, and we can choose explicit or recursive, I'm going to show you how to do both. If we start with the recursive, it would be f of x equals f of x minus 1. And again, you could use whatever variables you want. You could use v's and t's or whatever. I'm going to stick with f of x because I'm comfortable with that. And then my pattern at the end, which is times 4. We also need a starting value. So f of 2 is equal to 3. Or we could choose to write the explicit. So our explicit here would start off the same way. F of x is equal to our starting output, which in this problem is 3. And then our pattern, which in this problem is times 4. And then we're going to use an exponent because we're multiplying. So x and then get back to 0. So 2 means we would have to put minus 2 here. And again, that's because we want to get back to 0. And we need an exponent because our pattern is multiplication. Or another way to think about it is because this is a geometric sequence. All right, thank you guys so much for watching. That is the end. I hope you have a great day, and I hope that you study this weekend and get some practice time.